All right, here we go. Next lesson 26, Quadratics and Key Features with Technology. So a little bit of a break from all the number crunching at this point, except for for me right now, for showing one more of these to make sure you get the help you need. So let's go for it here. Let's run some numbers and see what this thing looks like. So let's start with our nice 0 spot, of course, because it's so easy. Gone and gone, so we have a minus 17, clearly way off the graph. So let's try some other numbers. Let's try a minus 1. And I'll draw the equation. We have negative 2x squared minus 12x minus 17. So if I'm putting in a negative 1, I'm going to have a negative 2 times a 1 from squaring the negative 1. So I'm going to have a negative 2. I'm going to have a negative 1 times a negative 12. So I'm going to have a plus 12. And I'm going to have a minus 17. So that gives me, I might as well just use a calculator to give the brain a break here. So we've got our negative 2 plus a 12 minus a 17. So negative 7. Just notice if you ever needed to, you really don't need the negative button. You can just start with a 12 and say, oh, take away a 7, take away a 2. Right? Gives the same number if you type it in right, hopefully. 12, take away the 17, take away the 2, gives negative 7 when you type it in right. All right, so we got a negative 7. Notice how that's closer to being, actually it's closer to being on this 5 by 5 grid. So at negative 1, we're at negative 7. So there. I think we're on the right track. Let's keep going this way. And I'll give myself some room up there. I guessed right. Here, if I had gone to the 1, it probably would have been even further down off of the graph. So the negative 2, let's go in. Let's have that be a 4. So a 4 times a negative 2 is going to be a negative 8. We're going to have negative 2 times negative 12. So we're going to have a plus 24. And we're going to have the minus 17. So let's do that one. We're going to have our 24 take away our 8, take away our 17. Negative 1. So very much on the right track now. Negative 1. So negative 2. We're at negative 1. 2, negative 1. Quite a difference in the spots here, just from 1 point. Eh? Let's keep going. Negative 3. So negative 3 squared is 9. 9 times negative 2 would be negative 18. Negative 3 times negative 12 would be positive 36. And the negative 17. Again, just use a calculator for any of those if you aren't comfortable with any of the arithmetic there. But the 36, take away the 17, take away the 18 is a 1. So now we're at 1. So at negative 3, we're at 1. Negative 3, we're at 1. And keep going. Negative 4. So negative 4 squared, you're going to get 16. 16 times the negative 2 would be negative 32. Negative 4 times 12, or negative 12 is going to be positive 48. And the minus 17. So we've got 48. Take away 17. Take away 32. Check there. Gives me a negative 1 again. So you can see we're going back down again. So we've kind of identified that middle spot where we're going to go down either way from it. So let's put on the negative 4 and negative 1. At that point, you can see some symmetry that's going to happen. You can predict that this next one is going to be down at minus 7 as well, so on. So I think we're done really there. We could double check that one, but really feel like we kind of accomplished it. Accomplished the goal here. So you can see this green one turned out to be the vertex. And so the vertex is at what? Negative 3, 1? Yeah, negative 3, 1. So you can tell that that number there is your maximum value, y equals 1. Your axis of symmetry is that x equals -3. And what else? We've got our y-intercept down here somewhere. So if I plugged in, at -17, right? So when x is 0, that graph is going to swoop way down to -17. So that's your y-intercept. Just, not really getting to it on this graph, of course. And then the zeros, I can estimate from this at best at this point in our math work here. So you might say something like, who knows, right? Maybe let's say it's 3/4 there. So that would be 1, 2, 2.25. So it might be like x equals -2.25 and 1, 2, 2.7. Right? No, not, 3.75. Anyways, you don't have to put a ton of work into that, though. You can just look at it and say, okay, we're at 1, 2, 3, so 3.75, and so on. I just was using, I put numbers in that would work, that would actually be symmetrical, so they could be right. If they're not symmetrical, they can't possibly be right. So I think that's it for that one. And so that's review. There's another one here. If someone wants to post a picture of that one or whatever in the help post area, I'll do that one as well. But I think I'm hoping maybe we're on track with that process. And it is a bit of a luck of the draw here. I kind of got lucky. With the 0 was obviously a good starting point. If I had tried the 1, it would have been worse. Then it would have gone this way. So it's really not too bad sometimes. But if you're in the wrong region of the graph, if I had plugged in numbers in this area, I would have had numbers like -1,000 or something. Like it's way too far off the scale. All right, so the new topic for today, though, is to be able to see these graphs with technology. All right, there's lots of neat ways that are available to us for graphing these now because of the day and age we live in. And so I'm going to show you my favorite, which is a program called GeoGebra. It's very powerful, but also very useful. It's fairly easy to use as well, even though it has lots of power to use in the future if you went on with it. So just Google GeoGebra and you'll get a search engine like that, result like that. Click on the graphing calculator one. It looks just like this right here when you load it up. We'd have to have it open somewhere here, but find where here. Here it is. Right, so this is the one I was going for there when you log into it or click on it or whatever. Okay, so just Google GeoGebra. Now mine knows me well, so it says, hey, do you want the GeoGebra graphing calculator like you did last time? And whatever, but just load it up. There you go. Okay, so that's the program we're going to use. Available on Google worldwide. And so this program here, in order to enter in equations, you just enter in the equation and it'll graph it for you. But there's just a couple little things that I'll just show you to do with that. The biggest one is to do x squared. You type in x and then some people call it the hat. So x hat 2. Hat, this little upside down V up in the air there, is really shift 6 on the keyboard. So I could probably do this actually. Probably could show, yeah, there it is right there. So if I did shift 6, right, it's going to type hat wherever this digital keyboard is typing. I'm not even sure where it's typing. So, but I'd have to, I guess if I wanted to do it for real, I'd have to put a text box in here. Then probably do this, shift 6. And it probably typed into that box now for me. There we go. Right? So that's the symbol there for x to the power of 2. And so if I went to the GeoGebra screen, it's going to be difficult for me again here. There we go. So if I do this thing here, I'll just use my digital keyboard so you can see what I'm doing. Maybe. There we go. So x, shift, hat, 2. And the graph just shows up right away. So there's that general basic quadratic that we started with. So you can see the pattern that we know and love and whatever. As we look at this, we're going to go over 1, up 1, and over 1, up 3, and so on. The next one will be over 1, up 5, just like we've talked about before. Right? So graphing with technology is pretty easy, nice and easy. When you click on that thing, it'll actually, like if you're not clicked on it, it doesn't show anything, but when you click on it, it'll actually show some dots. You can actually go to it and say, I guess it's different on more complicated ones, but this little dot that ends up here, if you click on it, it'll tell you what it is. And so I just touched it with my finger, but with a mouse, it'll do the same thing. So it's telling you that it's one of the roots, which is root solution zeros, x-intercept stuff. It's telling you also that it's the y-intercept in this case, right? Because it happens to be the x-intercept and the y-intercept. And it's telling you it's the extremum, which is the weird word for saying the extreme value, or in this case, the minimum, the most extreme lowest spot that it goes to, okay? So lots of information available there. So that was, I talked about that on the program, but there's the slide to do with it, okay? We can add on an axis of symmetry for this one. So it would have to have, just like we've been saying all along, right, an x value of 0. So if I was showing on this screen, I put the line there and say the axis of symmetry is x equals 0. Well, check it out. It actually works on here too. I can just say x equals 0. I can actually probably just type a 0 in, but let's just do that. Let's just do 0 and be done with it. It's doing weird stuff on me right now. Sometimes it does that and I get confused. I have to remember how to fix this here. So I'm hoping that I can just type in like x equals 0, and maybe that'll make more sense. So x equals, I'll get it right eventually. There we go. There, that blue line is the axis of symmetry. X equals 0. Okay. All right. It was an adventure. So when you go to do all these different graphs and so on, like I did the, let's do the new one that I just did here. Let's grab this page. Let's just sort of do this. Select all, group, Bobby, down here. Paste that one in, down here. And so have a small version of it so we can say, okay, yeah, does it match? Doesn't it match, right? So we're looking for y equals the negative 2x squared minus 12x minus 17. So we'll go and do that one. So here, let's get rid of this guy. And then here, we're going to add in everything else. So I think it was negative 2x. I'll just double check. Yeah, negative 2x squared. And here, right there, negative 2x squared. And then you have to sort of arrow over, so you're at the spot. You don't want to be adding in like in the exponent. You want to arrow over so that you're doing the next term. That's one of the little tricks that you have to watch for. This next one we wanted was negative 12x and then negative 17, or take away 12x and take away 17. That. So take away 12x, take away 17, hit enter, boom. And hey, look at that. Looks pretty similar to the one that we did. I'm just going to screen capture that in. There we go. So let me just grab a 5x5 or so grid, and you'll be able to see that it is the same. Right, same stuff. And we can also, in the program, click either on the grid, and it'll show a bunch of spots. The other thing you can do, and then you can look at it and be like, okay, it's going to tell you the extreme value is the negative 3, 1. So the vertex is negative 3, 1. The maximum value is 1. The axis of symmetry is x equals negative 3, just like we did here, right? Just the same stuff. In that, we could also click on the 0. So it's going to tell us one of the roots is at negative 3.70. We approximated it as negative 3.75. I missed a negative there, but we knew it. We knew what we meant, right? Royal we. Anyways, make a negative in there. I'll go back to the original page and make it. So that was supposed to be a negative there, of course. It was already in the negative area, the other one, even farther than this one. And then what else do I need here? Let's go to the graph. And the other 0 has negative 2.29, which I approximated as negative 2.25. You can tell it was pretty close. If you check, you'll find that the symmetry is correct here as well, right? Where's my page? Oh, here, there. So if you look at the number that they gave, the amount that you're in from each side, or the amount that you're out each way from the middle would be the same. But it's just not as obvious because it's not a nice number like 0.25, but it's pretty close. So yeah, that's about it. It's about all it's showing us there. I could go and look way down here, and it's going to give us a value. Maybe looks like, oh, there you go. So it gives us the y-intercept of the negative 17, which we already knew as well from the graph, or from the table of values that we did, I should say. So yeah, everything's working, right? And so we could also do that for this one here. This is the one that I posted a help video on to do with the second day, sorry, for the lesson 25. So we can do that one too, x squared plus 3x minus 7. So x squared, I just have to modify that 1. So it's just going to be an x squared, so get rid of this stuff. And then it was, remind myself here, plus 3x minus 7. Plus 3x minus 7. Hit enter, and we're way off the scale because I was looking at the y-axis and so on, but this one here should match the one that we did as a help example. So screenshot of that stuff. Let's just do it that way to make it easy. So that's the result we got from GeoGebra. Do I have? No, let me just grab it here. I'll just grab a screenshot of that. That was the video that was posted yesterday. Helping, giving some extra help on this stuff. So that right there, let's grab just that stuff, group, copy, paste onto here. So we can look at it and say, okay, are they the same thing? Yeah, we're crossing, just where do I want to put this? Move this one over, side by side like that. Right, so if I were to enlarge this one and make the other one smaller, then about the same size even, so you can see more easily. So this one goes down to about minus 9 and a bit. This one's down at minus 9 and a bit, and so on, right? And we're 1 point something over, 1 point something over, however many over this way. It looks like 1, 2, 4, 5 and a bit. Or is it just under 5? I guess that was an approximation though, really, right? So you can tell it's actually a little bit less than 5. But yeah, very similar stuff, right? In fact, actually, we had approximated, I think we did calculations to see the vertex was at negative 9.25. A moment of truth here. Oh, the other way you can do this, by the way, is you can say show special points, and it'll show all of the pieces, the actual values on the screen, instead of just having to click on each one. So there's that minus 9.25 that we calculated, or I calculated, or whatever, on the help video. Okay, so that's the digital version of the of part A of the work that you had done by hand. And so this is just the same questions again, but saying now just do it using tech and identify the features using tech and confirm all those results. Okay, and yeah. If you're trying to make an equation with tech for this part F, you'll still find that it's a little bit tough. You probably are recognizing now that you need like a minus 4, or sorry, just a minus 4x squared, so it's the same shape but upside down. Let's fix that here. Get rid of, or if I just delete that one, yeah, it's all gone. So we need a negative 4x to the power of 2, right? Which is fine. And then You might have started to notice too that if you put like a -6 in, great, that drops you down. But how do we get into this left quadrant? You might guess something like -3x or something. And it worked a little bit, but you want more. You want to go farther into that quadrant. So maybe like -13 and be like, oh, shoot, it ended up top. Okay, what if I -15 now? Okay, it's, you can play around with it, but it's a bit hit and miss. That's actually probably the better amount of result from guessing that I've ever done, to be honest. Usually it's really not even that guessable, let's call it. Anyways, so that is the graphing with tech version of things. If you need any help with any of these other ones, or just another kick at it, let me know. Post a picture either email me a picture and then I'll just make a thread, or just make a thread yourself. Either way works. All right. Cheers, everybody. Till next time. Hope that works for you.